Hello everyone, and welcome to another video on the wireless transmission technology. This time we have a full wireless network set up. So here we have 4 devices, which we call RUD cards, which stands for Redstone Update Detector. And these are a point-to-point network, which means that any of these devices can connect to any of the other devices directly. Over here, this is where we set the address to which device we want to send our information to. So here we are sending to binary 0 for the first bit, and then a binary 2. So this is sending to device 2. And this is the device ID of the one we are at. So this one's device ID 1. This is 2. This one's 3 because it's 2 plus 1, and so on. And this last one over here is 4. So we have 1, 2, 3, 4. They don't have to be in order. We just did that for simplicity's sake. And then how we make sure that these do not transmit over each other is each one of these has a priority value, and depending on which device has the highest priority, it will transmit first. So currently we have the priority set up so that this is the highest priority and the one over there is the lowest priority. And this is how we make sure that they can all communicate across from each other without interfering. And that is set over here. This is the priority ID. And to send a code, what you have to do is put it in send mode. So this signifies that there is an item packet that needs to be sent. And what an item packet is it is a shulker box with a binary code inside of it. So, for example, here is a packet of 011011011 and so on. The bottle signify a positive bit, and any other unstackable is a 0 bit. And that is put into here, and it will be sent to the correct card. It will be outputted here. And that's how we transfer our information. And the reason why we're doing that is because the system that will hook up into these cards will also be managing data using these packets. So I have these 4 example packets here. This one here. And I have this one with this pattern. This one has a little smiley face. And this one spells out LOL. Now, they could be any actual mathematical combination, but just for showcasing, I did those binary sequences. So if we grab all of these here, and in the first one, we grab this one, put it in here. Now it is already ready to send it with this light on. This lamp over here signifies that this is the one currently transmitting. Then we're sending this to number 2, so this is right here. So we should see this go right across to here. Then in this next one, we'll send this packet, and we shall send this one to number 4 all the way over there. This packet will go back all the way to this one will also go to number 4. So multiple packets can go to the same device, and the same device can also send out multiple packets. So this one actually won't be receiving any. And this one's going all the way back to 1 where we were at the start. So we put this in here. And it is ready. And the method of syncing all of these together, since they need to be clocked at the exact timing, is that we use a daylight sensor. In the survival world, we'll have a much more complex syncing circuit using different changes in the time of day, not just going from night to day, but just for showcasing, we have a button that turns it from night to day really quickly so that all of these activate at the same time. Okay, so now Totem for me is going to press the button to sync all of these circuits up. You should see the correct lamp turn on. So this one over here is transmitting. So now the box has been dispensed in this one, it is being unloaded, and then the 8 game tick serial coming from the box is now being compressed into 2 game ticks. So you'll see it unlock at the last second, is being transmitted, and now it will be loaded into this data cell, which it is. Here's that data of the 1001000. And if we come over here, it's now being transmitted. Over here, there's an inversion because of the nature of the data. And once that's been transmitted, it should be broken and put into here. So there's our first blocks transmitted. Then now it is this one's turn. So you can see this one's now transmitting and is unloading. The data is being loaded into here again. And just like that, it will reset and transmit in a second. And second now. And there's our data. This is the one with the bottles in the middle and a ring of shovels. And this one now should be loaded in here. A second. Here's that we are on the next one. Now this one's transmitting. I forgot this one didn't get sent to here, it gets sent to here. This one doesn't receive any. So this is the one that should actually have the box. Any second now. And it's to finish. And we know that everything is done when this turns off. That is when this is the master cycle switch. This is an emergency stop button. But currently it's still transmitting some more data. So this one is now transmitting back to the first one. Should be done soon. Oh, here's that one. And any second, this one says it's finished transmitting, so it's off. And it should pretty much be done now. All these latches are off. And it's just doing one last empty cycle to finish everything off. But the transmission itself is all completed. Sorry, I got disconnected from the server.
I got disconnected again.
Oh. Okay. But you can see here everything was transmitted. So if you check in this box, oh, again, sorry about that. Let's rejoin. But if I don't get disconnected again, I can show you that the data packets did get served correctly. And, well, I might have to record this at a different time. Alright, I'm back on my mobile connection, so I shouldn't get disconnected. But you can see here that we have our first packet, and has indeed been transmitted correctly. So from this one to that, and these bottles are in storage here. This is just a temporary extra storage that we used for testing, but the bottles do get recycled. So they go through this circuit that determines if it's a bottle or not, and then they go up this dropper elevator into this loading setup that loads it with the correct bottle and shovel order. Over here on this one, this is just a shortcut that we accidentally left in here from testing, but you can see the LOL signal did get transmitted correctly. And we don't really have a method of swapping these transmissions because that's up to how you set up your actual brain part of these chip cards. So we just have the player manually input the address, but there is no reason why a card shouldn't be able to send it to multiple addresses, as these orange and red bits are what determine which card gets the signal. And these yellow ones are the data bits, 27 of them in total, each for one of the slots in a shulker box. And how we transmit wirelessly, in case you didn't see the last video, is that by updating water, we activate what is called a redstone update detector, which by abusing some mechanics of how the game calculates redstone, we can wirelessly transmit to these broken torch circuits. So you can see, here's one for example, they are both off, and the dust is also off, which is an impossible state, and any update to the redstone system, such as placing this observer, will pulse it. And that is basically how we decode the information. So each pulse corresponds to a single bit. So this is all serial, and it is at 2 game ticks and extremely fast. This is just a light showcase since this is a older version. We are working on a lot simpler, or not simpler, but an easier to use version that is also a lot faster in terms of cycle speed. And once that is out, that will be available probably to the public, since it will be a modular design, so players can use it however they want. This one's very proprietary, everything's attached, and there's no other way to input. You have to use shulker boxes. But other than that, that is it for this video. Thank you for watching. See you in the next one.